Hey everybody, welcome. In today's video, we are going to review all of the different types of transformations that we've done in the previous few days when it comes to linear functions. So I have here a little refresher, study guide, cheat sheet, whatever you want to call it, note card. You can totally feel free to pause this video at this spot or come back to this this timestamp. Remember how many seconds we are into the video right now, because this is going to help you recognize what type of transformation is going on depending on how the equation or how the function looks. And so a few days ago we talked about vertical translations. Remember, vertical translations are always going to have adding or subtracting after the letter x, right? This would be 2 places up. This would be a vertical translation 2 units down. That's going to slide it up. It's going to slide it down. The other type of translation we had was horizontal. This one you don't see as often. Remember, on these, the adding or subtracting part is inside the parentheses with the input number. The letter x is what it usually is. It doesn't have to be an x, but it's always going to be in parentheses with that input. This would be actually 2 places to the left. Remember, these horizontal ones are always backwards from the way that it looks. This is 2 to the left, and this is 2 to the right. Okay, so that was translations, slides. Over here in the purple, we have the reflections. Whenever they put a negative sign out in front of the letter F and then the letter X or whatever it is, the negative sign is out in front. That is a reflection in the x-axis, or you could say a reflection over the x-axis. And when that negative sign is inside the parentheses with the input, usually it's the letter x, but it doesn't have to be, that's a reflection in the y-axis, or a reflection over the y-axis is how some people say it. Okay, down below in these bottom 2 little boxes, we have the horizontal shrinks and the horizontal stretches, and then the vertical shrinks and the vertical stretches. The horizontal ones are always backwards. They hurt my brain. Sorry, I keep shaking the camera there. They hurt my brain a little bit more. The horizontal shrink is going to look like this. There's always going to be a letter, in this case called A, but it's actually a number in the parentheses that the input is being multiplied by, and that number is going to be greater than 1. For example, I don't know if you can see this in green. It says y equals f, and then in parentheses I have 2x. And so that number, in this case the number 2, the A represents that 2. The A and the 2 are basically the same thing. And that number is bigger than 1. So if you have a number in the parentheses bigger than 1 being multiplied by the x, like up here it was being added and subtracted, here it's being multiplied by the x, and it's a number bigger than 1, you actually have a horizontal shrink, which seems backwards, that a number bigger than 1 would be a shrink, but it is when you're doing horizontal. And then the horizontal stretch is going to look the same. The number is going to be in the parentheses. The number that the x is being multiplied by is in the parentheses, but now that number is going to be a fraction in between 0 and 1. That's what this means out here. It means the letter A, the number in the fraction, is in the number in the parentheses, excuse me, is in between 0 and 1. So here, I don't know if you can read it, it says y equals f, parentheses, 1/3 times x, and then I close the parentheses. So that number 1/3 is the letter A, and that number is less than 1. So I'm actually going to call this a horizontal stretch, which seems backwards, but it is. Okay, the vertical shrink and the vertical stretch are the last 2. These are much more common. These are much more straightforward. On these, the number that we have in the letter A location is going to be out in front of the parentheses. It's just going to be like y equals some number times whatever, and that number is going to be bigger than or in between 0 and 1 when we're doing a vertical shrink. We're going to shrink something down. That number is going to become smaller. The slope is going to get less than 1. And so like I put an example right here in green, y equals 1/3 f times x. Remember, see how the 1/3 here is outside of the parentheses? And on this one, the 1/3 is in the parentheses. That's how you can tell it's vertical instead of horizontal. And then the other vertical one is a vertical stretch. This is my favorite one. This one happens the most often, I think. You'll have the number in the letter A location out in front, like we do right here. It's going to be multiplied by the f of x, and the number is bigger than 1. That's going to be a vertical stretch. The vertical ones are easy. It's only those horizontal ones that kind of are backwards, and so they always kind of make me stop and think. But the good news is those horizontal ones don't show up very often when it gets to questions. So what are the questions going to look like today? Most of the questions today are going to ask you to graph these 2 functions and then tell me to describe, it's going to ask me to describe the transformations from the first one to get to the second one. So we're going to have two lines on here. They're going to ask us, what did we do to move the first one into the second one? So here is the first one that we've seen numerous times throughout these last few lessons. It's the parent function y equals x, or f of x equals x. Like, this is the same thing as the letter y. So if I wanted to do my little table, whoops, I already messed up. Sorry about that. If I wanted to do my little table, I could put the x and then the f of x, or you could put a letter y right here. Pick whatever numbers you want. I say pick easy numbers, and then you just plug it in. If I put a 1 right there, it would just say f of x equals 1. And this is the easiest one because there's no adding, there's no subtracting, there's no multiplying, there's nothing going on here. You just, whatever number you put up there, that's the answer, 2, 3. And then I graph that, and over here I would graph it. It would go 1, 1, 2, 2, 3, 3. Has a slope of 1, goes to the origin. It's the most basic line, the parent function that you can graph. Okay, that's the easiest one. And now look, we're going to change it. Let me switch my colors to, I think the orange stands out pretty well. Look at this one. Now, I hope you all are good at just graphing this on your own. Like, I don't think it makes sense to do an x and y table for this one, right? I think we should know. Now, you could do an x and y table or an x and an f of x like we did right here. You can do one of those, but I don't really think it makes a lot of sense if you just know how to graph something in slope-intercept form, right? This number at the end, the -2 at the end, that is your y-intercept. So I'm going to go to the y-axis. I'm going to go down 2 because it was -2. I have to go down 2 and put my first point, right? If that would have been a plus, I would have gone 2 places above the origin. But since it was a -2, I'm going to go 2 below. And then this number right here, the coefficient on the letter x, whatever the letter x is being multiplied by, that is the slope. The slope is a positive number. It's positive 1/4. So that is an indication that I'm going to go up, 1 up, 4 to the right. If that would have been a negative 1/4, I would have gone down 1 and then 4 to the right. You always go to the right. Up 1, 4 to the right, 1, 2, 3, 4. Do it one more time. Up 1, 4 to the right, 1, 2, 3, 4. Boom, I have them both graphed. That took me a little bit more time than it would have if I was just not having to talk about it. This is the h of x. Whoops, I already smeared that. I could actually write the whole equation, but I'm not going to just to save time. So what did we do to take this blue one and turn it into the orange one? I don't want to hear people say, well, you moved it? Well, duh, yeah, of course we moved it. But what specifically did we do, right? So what we need to do is look at how does this equation right here look compared to this one. Okay, the first thing that I notice, this had an original slope of 1, and this has a slope of 1/4. So what is that? Whenever there's a number out in front, look what we did. Just like on this one, there's a number out in front that it's being multiplied by, and that number is less than 1. Like here's where the number is bigger than 1. This number is less than 1. This is a vertical shrink, right? We made this line flatter. Instead of being steep like this, now it's flatter. I could walk up this hill a lot easier than having to walk up this hill. And so what we have done, describe the transformations. Notice transformations, plural, there's more than one. The first thing we did is a vertical. Most of these today are going to be vertical. In fact, I think they might all be. I could be wrong on that. Vertical shrink by a factor. How much did we shrink it? It's always going to be the slope number. Well, it's for the most part going to be the slope number. We took it from 1 and we shrunk it down to 1/4 by a factor of 1/4. And then what else did we do? Well, we have a -2 at the end. Was there a -2 at the end on the original one? There was not. And so what we ended up doing is we put a -2 at the end. Look back at your table. -2 at the end, right here. A vertical translation. So the second thing we did is a vertical translation. And how many units down did we move this? We moved it down 2 units. Down 2 units. And you can see that right here. The original one, the blue one, crossed the y-axis at the origin. This one crossed, boom, boom, down 2 units. Those are the 2 transformations that we did. This one here, whoops, let me get it on camera. This was the original. It was just y equals x. and we changed the 1 to a 1/4, so we shrunk it by a factor of 1/4, vertical shrink, and then we added this -2 at the end. And so when you put that -2 at the end, that's a vertical translation, 2 units down. Okay, that's what the questions are going to be today. They're going to have you graph them, and they're going to have you tell what you did. Now, I'm not going to graph all these examples because that would take way too long, but I'm going to hopefully give you a little practice at the description, because if you can get the description taken care of, it's really the hardest part. So describe the transformations from F to H. Most of these say F and H. I know a couple here at the end do not, but the majority of them do. So here's the basic one. Look what we did on this one. Instead of a 1, we've changed it to 2/5. So this number is smaller than 1. When you have we have it shrunk down here, the slope has gone from 1 to 2/5. This is a vertical shrink. I'm just going to abbreviate by a factor of 2/5. And then what else did we do? This one doesn't have any adding or subtracting on it, but look, all of a sudden this one does. It has +1 at the end. That's a vertical translation or slide. I'm just going to put like that to abbreviate it. 1 unit up, or up 1 unit. You can say it either way. It's not going to bother me. Okay, I'm going to kind of alternate here between colors so you don't get them mixed. This one, number 2 here, on my second little bullet point, that's a normal one. And look what we've done. We've changed the 1x to a 3x. So we have made this line actually steeper, right? The slope has gone up. The slope went from 1 all the way up to 3. So this is a stretch because we've made it, we've made the slope higher. And then how much higher? Well, what do you have to multiply? 1 times what would equal 3? That's 3 times as much. So we've increased it by 3. And then what else did we do? This didn't have any adding or subtracting on it. This one has a -2 at the end. So when you do a -2, that's a clue. This is going to be a translation, vertical translation. And then we moved it 2 units down because it was subtracting 2. If that would have been a +2, we would have had a different answer, right? Let's try purple for the next one. Right here is the basic one, just like normal. Here we have, we have a -3. Holy cow. Okay, the negative means you have done, let me get my other board. You can't even see it because my arm smeared it. The negative out in front means you have a reflection in the x-axis. We've changed the sign. Here it was +1, here it was -3. Before I even need to look at the 3, this was a positive, this is a negative. So that's a clue that we've done a flip or a reflection over the x-axis. So we reflected this over the x-axis. That was step 1 because the sign changed. That takes care of this, right? I changed the sign from positive to negative, but then we also changed how much. This was a 1 and this was a 3. And so we've made it 3 times as steep. This is a vertical stretch by a factor of 3, just like the last one was a vertical stretch by a factor of 3, the orange one. And then we also added this -4 at the end, and that is a vertical translation or slide. We've shifted this line 4 units down because it was a -4. Wow, that's a hard one, right? That should be the most answers they give you, 3 different things. When the sign switches from positive to negative or from negative to positive, when the sign switches, you know you have a reflection. Whenever this slope changes from 1 to 3, when those numbers change, you know you have a vertical stretch or a vertical shrink. And then if they put a minus or a plus something at the end that's different, you've obviously got a vertical translation. So here on this one, the next one, we have just the basic one here that starts with a 1. And now look, all of a sudden, we've got a negative. This was a positive, this was a negative. Immediately when I see that, I'm going to put reflection over the x-axis. That's the first thing they did. I haven't even looked at the number yet. I can tell that's what happened just by looking at the sign being a negative. Now, what happened with the numbers? We had it at 1, and now we have it at 1/5. So it's gotten smaller. That is a vertical shrink. It's a vertical shrink by a factor of 1/5. I'm just going to put 1/5 just to save time. And then we also put this +2 at the end. When you put the +2 at the end, that's a vertical slide or translation. You put translation or trans with an L there. And this is up 2 units. Whew. These can get kind of lengthy, can't they? I didn't really expect to be doing this much writing. Feel like I'm in an English class. Okay, last couple ones. I'm so sorry if this screen is shaking. I keep moving the table because I can't sit still. The next one. This one is a little different. Look, all of a sudden, uh-oh, we started with 2x, and now we have 8x's. So we've definitely increased the slope, but how much did we increase it? All these other ones started with 1. 1x, 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 whatever. This one starts with 2. So we bumped it up from 2 to 8. We've increased it by a factor of what? Don't think about adding and don't think about subtracting right now. Don't say, oh, you added 6 to the slope. No, 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 no. When you talk about the slope, you need to think about multiplying. What did we multiply this by, right? 2 times 4 would give us 8. So this is it's a vertical stretch because we made it bigger, but it is by a factor of 4 because it's 4 times greater than it was before. 2 times 4 would give us 8. We multiplied it by 4. Do not think of adding and subtracting. That's the wrong path to think about. Now, we also put this minus 2 at the end. That's a clue that we did a vertical slide or a translation by a factor of, oh, no, not a by factor, just 2 down, 2 units down. And I'm running out of room. Let me erase some of these earlier ones just to give myself some space. Let me erase some of these up here. Actually, you know what? I'll even erase the last one. Okay, last couple, then I will be done. Look what we have here. We started with 4x. And now look at this one. It's negative 4x. So we went from positive to negative. That immediately tells me we've done a reflection over the x-axis. The fact that the sign switched, not even looking at the numbers yet, positive switching to a negative means you have a reflection over the x-axis. Now, did the slope actually change? I mean, the 4 and 4 is the same, right? The number part here, 4 and 4, is the same. So we didn't actually do a stretch or a slide, or stretch or a shrink, sorry. We just flipped it because the 4 part didn't change. We just made it a negative, and when you made it a negative, that was the reflection. So really the only thing else we need to say here is we did a vertical translation up 1 unit. Okay, grand finale. This comes from a word problem in the book. If they switch the letters on you here, this is a P. Don't let that bother you. Here's your original equation. And now look here at your second one. That is a 50. It's kind of hard to read because my hand actually hit it and erased some of it. Okay, it's positive here, it's positive here, so I don't need to do any reflection stuff. The signs are the same, but we have a different slope. It's gone from 5 to 15. So it's definitely a vertical stretch. What is the factor, though? What do we multiply this by? 5 times what equals 15? 5 times 3. My 3 looks kind of pathetic right there because it blended into the arrow. So this is a factor of 3 because we made the slope 3 times 3, multiplied it by 3. And then this started out as minus 100, and this is now minus 50. So think about that on a number line. If I'm all the way down here at negative 100, way down in wherever, and then the second one is up here at negative 50, what have we actually done? We started here and we went here. We've moved it up 50 units, haven't we? So this is a vertical slide or vertical translation up 50.